Okay, I'm sorry in the last video I wasn't using my good microphone. So where we left off in the last video was we had decided, we derived the equation for a basic circle, like an untransformed circle, radius 1, centered at the origin from the Pythagorean theorem. Then we decided to right shift it and upshift it by replacing x by x minus a and y by y minus b. And I said that if you multiply them all out, you'll very frequently get something that looks like this. And when you see something that looks like this, you should think, aha, I see an x squared and a y squared. Like maybe this is a circle, and you should complete the square in order to simplify it. So that's what we're going to do in this video. All right, so if I'm going to complete the square for this left side, I've got... let's see, so I've got the x times x will be x squared. This must be 5 halves, because if I'm going to expand this like that, I'll have the x squared, I'll have I'll have minus 5 halves, I'll have another minus 5 halves, and so when you put those together, that gives me negative 5 total. And then I'll have this extra plus 25 over 4, so I'll subtract a 25 over 4 to compensate, to subtract away the extra amount that I'm adding when I multiply those two terms on the outside. Okay, so let's write this over here, 25 over 4 squared. Okay, so now I've completed the square for the x. Let's complete the square for the y. It'll be the same deal. So here I'll get an extra 1, so I'll subtract a 1. But what I've forgotten here is we've got another, like the plus 10 is still there and the plus 9 is still there. So now let's take everything that's not the x squared term and the y squared term. Let's take all these constants and move them all to the other side. So I'm going to add 25 fourths, I'll subtract 10, I'll add 1, and I'll subtract 9. So when I've done that, I've got negative 5 halves squared plus, this is a plus in here, plus y plus 1 squared. And then let's see, I've got the 1, and then let's start on this side. So plus 25 fourths, took care of that, minus 10, took care of that, plus 1, took care of that, minus 9, took care of that. Okay, and so now let's simplify on the right-hand side here. So I've got, what do I have? So I guess minus 10 and minus 9 make negative 19. Plus 1 is negative 18. Plus 1 is negative 17. Okay, so this is negative 17 plus 25 fourths. So let's rewrite the negative 17 as negative 17 times 4 divided by 4. Okay. Let's leave that where it is for the moment and let's step back and assess. So a couple of things. You might have thought, looking at this number 1 initially, that this circle has a radius of 1. But if you remember, the radius of the circle is going to be the square of whatever your constant on the right-hand side ends up being when you only have the x squared and the y squared term on the left. So after simplifying, we see that the radius of this circle is not 1, it's actually this. And if you think about this, it's going to end up being a negative number because I have 25 minus something larger than 25. So I just made up these numbers without thinking about it very hard. And so I think there's a couple of important lessons here. One is that even if the form of your answer on the left-hand side really looks like a circle, this is a thing that might happen. You might end up with something where there are no xy coordinates that could possibly satisfy the equation at all. So this graph is the empty set. There are no points in the graph of this equation. Sort of equivalently, there are no sets of values x and y which would satisfy the original equation. But let's go ahead and modify it. Let's say this had been plus 100. So in that case, we would have had, instead of plus 1, we would have had plus 100, which means that we would have had an additional 99 times 4 up here. So now, if this is what it had looked like, now on the right-hand side we have a positive number. Let's work out what it would be. So after simplifying here, we've got 553 divided by 4. And remember, that is the square of the radius. So at the end here, we've got an equation that describes a circle that's been shifted right by 5 halves. It's been shifted, down by 1, because it's like subtracting -1. And then the radius is square root of this thing. 353 divided by 4 is 88 1/4. So it would be square root, like roughly square root 88. So that's the big picture. The big picture is sometimes when you're working algebraically, and this is going to happen to you probably next class, you'll be working on some totally different problem, and you may end up with an equation that looks like this, and you shouldn't just say, well, it seems like I'm done. You should realize, aha, maybe I could complete the square and simplify it a little bit further. And once you've simplified it, you may get to a form where you recognize, oh, that's a circle, and now I know where the center is because I know how it's been shifted, and now I know what the radius is because I know this term is radius squared.